So welcome to this class on balancing chemical equations, and I'm going to be teaching you some secret tricks on how to balance chemical equations. And I'm very confident that once you watch this entire class, so once you watch the whole class, you'll easily be able to balance any chemical equation. So I'm going to make the concepts of balancing of chemical equations really easy for you. Okay guys, so do make sure you watch the entire class, and I'm sure you'll find it really easy. And guys, as you know, I have my YouTube channel Manocha Academy, and I have a website manochaacademy.com where I put these physics courses for class 9 and class 10. So all of you, please do check it out. And yes, I do have real big discounts on these courses for you on both the physics class 9 course and the physics class 10 course. So guys, do check out the link manochaacademy.com, and I'll also put it down below. All right. So welcome everyone. Hi, welcome. I see a lot of folks are here. Hello. So welcome to this class. As I told you, it's on balancing of chemical equations. And so this is for anyone who's from class 10, class 9, class 7 or class 8. Anybody who wants to learn balancing of chemical equations, or even if you're in class 11 or 12. Okay, because I'm going to show you some really simple tricks and the techniques of how to balance any chemical equation. And I'm totally confident you'll be able to balance any equation after watching this video. Okay guys, so let's get started. So what are the ways to balance a chemical equation? In this video, we'll be talking about the table method, the hit and trial method here. So these are the methods we are going to be covering. The table method, I'll teach you the hit and trial method, and a very important method called the ABCD method. So, and one important thing, patience and practice is very important. Okay guys? So to balance chemical equations, you must have the patience and practice to do it. Okay? And with practice, you'll find it really easy. Now, I'm sure you've gone to the vegetable shop, right, to the fruit seller, and you've seen this beam balance, right? And what do they do there? They're basically balancing the mass. So all of you know that they go ahead and put weights here, right? So this, on this pan, they're going to put some weights. And what do we say? They're balancing the weight of the apple with these, or in physics terms, we say they're balancing the mass. So the goal here is they're trying to balance the mass, or we can say balance the weight, right? So that is one thing to visualize about what is balancing of stuff, right? So you use a beam balance, but in this video, we are going to be balancing chemical equations. Now let's see, what does that mean? So let's say we have our equation here. Let's say it's hydrogen plus oxygen is water. And as guys, as you know, that this is called a word equation. And that needs to be converted into a chemical equation, right? So word equation needs to be converted into this chemical equation that you see here. Can you see? H2 plus O2 is H2O. So I'm sure all of you know how to convert a word equation to a chemical equation, right? So how to do this conversion. And if you don't know that, I have a video on how to write chemical equations. So do check it out. It's on my channel Manocha Academy. So you must know this first step of how to convert a word to a chemical equation. And what's the basic idea? You know that hydrogen, one molecule of hydrogen is H2, as you can see here, right? One molecule of oxygen is represented by O2. We don't write O because the atomicity is 2 for both hydrogen and oxygen. And one molecule of water is H2O, right? So it's not H2 plus O2 is H2O2, okay? Because we know based on valency, the molecule is H2O. All right, I'll share a link, or you can just search chemical equations and reactions Manocha Academy, and you'll find that video, right? So this is what is known as a chemical equation. I'm sure all of you have seen this. Now, one important thing is, what are we trying to balance and why? Just like the fruit seller is trying to balance the mass of the apples and the weights, here we are trying to balance the mass of the reactants. So mass of reactants here. And what are the reactants? The guys on the left hand side, right? You guys know. So hydrogen and oxygen are the reactants, and we are trying to balance that, so that should equal to the mass of the products. That's our goal. And what is the products here? The guy on the right hand side, water, right? So first let's take a look, is this equation balanced? What does it mean by balancing mass? So guys, do you know what is the mass of one hydrogen atom? So what is the mass of one hydrogen atom? Tell me. So the mass of hydrogen atom, very good. I see a lot of you are writing 1U, excellent. So you know the atomic mass is represented. So hydrogen is 1U, right? Where U is the atomic mass unit. So H2 is basically going to be 2U, right? So 2 into 1. Now what is the mass of one oxygen atom? As you guys may know, oxygen is 16U, right? So oxygen molecule is going to be 16 into 2, simple. That's going to be 32U, right? So hydrogen atom is 2U and oxygen atom is 32U. Okay, now let's look at the mass of this water molecule. So can you tell me what is it going to be here? So it's going to be 2 into 1U, right? Plus 16. So the mass of one oxygen water molecule, sorry, is 18U. Very good. I see a lot of you are writing 18U. Excellent. So now if we add up these masses, right? So if we just take this equation, which we know is not balanced, but let's take a look at this equation and let's see why it's not balanced. So if you sum these two masses, so 2U plus 32U, so how much do we have on the left hand side? We have 34U. And on the right side, we have 18U. So this is the important thing. Can you see, guys, that the mass of the left and right hand side is unbalanced? So if we go ahead and place hydrogen on this left pan, right, and oxygen over here, and if we place this H2O over here, you can see that the mass is unbalanced right now because it's 34 here, 34U, so it was H2 plus O2, and it's 18U here, right? So this beam balance is going to turn this way. So the beam balance will turn this way. So what is very good, someone has written. So I was going to ask that question, why are we balancing it? Because the law of conservation of mass needs to be followed. This is not possible, that you cannot have that mass of reactants is more than products or mass of products is more than the reactants, because we know in a chemical reaction the law of conservation of mass states that mass can neither be created nor destroyed, so the mass needs to remain the same. Okay, so this is the important thing, that we are balancing the mass of the reaction. So mass of reactants should be equal to mass of products. And now you guys know for this simple equation, so which I'm going to teach you the balancing, but you know the balance equation is going to be 2H2 plus O2 is 2H2O. We'll take a look why and how to get that. So now let's check the mass of the balanced equation. So this is our balanced equation, right? 2H2 plus O2 gives us 2H2O. Okay. So now if you calculate the mass, let's see how much do we get on the left hand side. It's going to be 2 hydrogen, 2 into 1 and into 2 here. So hydrogen is 4U plus oxygen is 32U. And how much is 2 water molecules? 2 into 18, right? Which is equal to 36U. And if you add up the left hand side, can you see 32 plus 4? That's right, 36U. So now you can see these guys are equal. Can you see that? That the left and right hand side will be equal. So this means to balance this beam balance, if you visualize it like this, you should have 2 hydrogen molecules here, 1 oxygen molecule and 2 molecules of water here. So this is going to become 36U, and the left hand side will also be, the reactants will also be 36U. So is that clear, guys? So we are, please remember, this is a very famous question. Why are you balancing chemical reactions? To satisfy the law of conservation of mass. And as you can see, once the equation is balanced, if you apply the masses that you know, like hydrogen is 1, oxygen is 16, you know carbon is 12U, whatever the mass you use, you're going to get the left and right hand side, the total masses equal. That's right, someone has written, so 36 equal to 36. Excellent. So that is the key concept. But now there's one simplification. we actually don't have to bother about masses when balancing chemical equations. We can simply balance the number of atoms of each element. So it should be same on the left and on the right hand side. So can you tell me how many atoms of hydrogen are there for this balanced equation here? So 2 into 2, 4, right? So can you see that on the left side there are 4 hydrogen atoms, and on the right also you can see there are 4 hydrogen atoms, because 2 into 2 water molecule, 2 into 2 water molecules, so that's 2 into 2, 4. And oxygen is going to be, you can see O2, so there are 2 oxygen on the left, and how many on the right? We have 2 water molecules, so 2 into 1, that's 2O. So can you see there's 4 hydrogen on the left and 4 hydrogen on the right, 2 oxygen on the left, 2 oxygen on the right. So this is an important simplification. We don't have to worry about masses in the balancing equation topic. You just have to balance the number of atoms of each element, right? So every element, the number of atoms need to be balanced, because you know the element cannot change in a chemical equation. So the left hand side for hydrogen or any element, the number of atoms should be same on the left and on the right. Clear? So please keep that in mind. Excellent. Now let's go ahead and as I promised you, I'll be discussing these important methods to balance chemical equations. So we'll look at the table method, hit and trial method, and the secret important ABCD method. And I'm confident that once you've understood these methods, you can easily balance any chemical equation. Okay guys, so let's go ahead and get started. And of course, if you have any doubts, please put it in the comments below. I'll try to respond to your comments as soon as possible. And guys, do hit the like button for this video and do share it out with your friends. So let's take a look at the table method. This is the most basic, simple method that we should know. So what is the first step? Make a table of the number of atoms of each element of the left and right hand side. Okay, so I'll show you with an example. And remember to start by balancing the easiest element. Just like when we are doing, we are studying, we tend to start with the easiest chapter, right, in the syllabus, so that our confidence becomes good. Same way here guys, start with the easiest element, not the most difficult one. And then keep on going till the table is balanced. And remember, I told you, patience is the key. Don't lose hope, keep trying it, and I'm sure you can balance it. So let me show you how to apply the table technique. So what is the table method? First, make these columns of elements, left hand side, right hand side. So what are the elements in this equation? The elements are, so these are our 3 columns here. So elements, as you can see, are hydrogen and oxygen. So guys, can you tell me how many hydrogen atoms are there on the left hand side? So just as we saw earlier, can you see it is H2? So that's 2 hydrogen atoms. So remember, here in the column of elements, just write H and O. Don't write H2O2, because we are looking at the number of atoms of each element. And how many hydrogen atoms on the right side? Very good, it's 2. And again on the right also it's 2. Now how many oxygen atoms on the left? Can you see it's O2? So it's 2 here and 1 here. So we made this table. Now the first thing to check, is the equation balanced? As you can see, it's not, because hydrogen is balanced, but can you see that oxygen is less on the right and more on the left. So oxygen is not balanced. Now what's our table technique? Start by balancing the easiest element. Since hydrogen is balanced, we don't have to worry about it. So the only other element is oxygen here. So let's start with oxygen. So since oxygen is less on the right, we need to multiply it. Okay, so can I do something like this? Can I do H2O2 and balance the equation? I can't do that, right? Because I'm changing the formula. H2O is water, but H2O2 is hydrogen peroxide. So please remember this important point. You can't make any changes in the formula. That's not what you can do. So what you can do, because the chemical formula is fixed. So what we can do is multiply here. So multiply in front of the formula and try to use the smallest possible number. So here, since we need to get 2 oxygen, so we'll multiply by 2. And so if I cancel this, oxygen is going to become 2. So it looks nice and balanced. But how many hydrogen will there be on the right now? It's going to be 4, because 2 into 2. 2 multiplied by 2, 4. Okay, 2 times 2 is 4 there. So can you see oxygen is nicely balanced, but oops, we have disturbed hydrogen. But guys, don't worry, we'll balance hydrogen also. So again, we look at this table. So oxygen is balanced. Next, our goal is to balance hydrogen. Now, can you see hydrogen is 2 on the left side. So can you see it's 2 here, but more on the right. So to balance it, we need to multiply on the left side. And we are going to multiply by 2 here, right? So I'm going to multiply this equation by 2 on the left side. And so what it's going to become? So on the left side, we are going to get 2 times 2. So that's 4. Now you can see in this table technique, the equation is balanced. Can all of you see that? Right? So our equation is balanced here. And look in the table, if you look at each row, so hydrogen row, you have 4 and 4. Similarly, oxygen, you have 2 and 2. So our equation is balanced. Excellent. Now let's apply the table method here for this equation. So again, to revise, so guys, you can use a pen and paper and try this yourself. So make these 3 columns, elements, left hand side and right hand side. And what are elements here? It's iron, hydrogen and oxygen. Note I'm not writing H2O2, right? Fe, H and O. Now let's look at how many elements of iron on the left side. Can you see? There's one atom, how many atoms of each element, right? So number of iron atoms is 1 here. Can you see that? So 1. And how many iron atoms on the right side? It's 3. Because you have Fe3. So that's 3. Now how many hydrogen on the left side? H2. So we're going to have 2 here. And how many on the right? Again, it's 2. And how many oxygen on the left? Can you see? 1. And oxygen on the right side is 4. So very important, make this table carefully. And first you check, is the equation balanced? No, because you can see hydrogen is balanced, but iron and oxygen are not balanced. Okay. So let's apply our table technique. That was our method, right? So make a table and start by balancing the easiest one. So let's start with the hydrogen is balanced. So let's start with iron, since iron is not balanced and it's easy to balance it. So 3 times iron. So that's going to be 3. And you can see we have balanced iron. Now the next guy left is oxygen, right? So can you see oxygen is 4 on the right side? So to balance it, I need to multiply. I can't make any change to the formula. So I'll multiply by 4. So it's going to be 4 times 1. So that's 4. But note carefully, we have disturbed hydrogen because it's 4H2O. So 4 times 2, hydrogen is now going to become 8. Simple. Okay. But can you see that iron is balanced, oxygen is balanced, but hydrogen is not balanced. So to balance hydrogen, very good. I am seeing a lot of you are balancing and writing the correct equation in the chat. Excellent. Well done. So we need to multiply it by 4 here to balance it. Why? Because we need 8 hydrogen. 8 is on the left side. So to get 8 on the right, we'll multiply by 4, not by 8. Because 4 times 2 will give us 8 atoms. So simple, just use a pencil or pen and cancel and keep making updates in the table and then finally check it. Because checking is very important. You can see iron is balanced 3 and 3, hydrogen is 8 and oxygen is 4 and 4. Clear? So this is how you balance it using the table method. Now let's take a look at one last one. This one is a little more complicated. So let's try the table technique for this. So we'll again write the elements, left hand side, right hand side. Okay. So what are our elements here? Lead. Is the element nitrate? No, because we need to break it down, right? Nitrogen and oxygen. We are writing the table of elements. And again, we'll do the count of the number of atoms of each element. So lead is 1 on the left side. Can you see? So we have 1 lead here, and right side also 1 lead. How many nitrogen do we have on the left here? So can you tell me, guys, how many nitrogen on the left? Is it 1 or is it 2? So how many nitrogen atoms on our left side? Somebody saying 1, somebody saying 4, 2. This is very important. So in nitrate, can you see? So in NO3, can you see that there's only 1? So if I write it, so this one is N1O3, right? It's NO3, but it's times 2 because there's NO3 whole 2. So you need to multiply this 1 and 2. So nitrogen is 2 on the left, and how many nitrogen on the right? 1. Clear? Now let's see how many oxygen atoms on the left side. So oxygen is 3 times 2. Can you see that, guys? So it's 3 times 2. So that's going to be 6 oxygen on the left. Okay, very good. 6 is the right answer. And how many oxygen on the right side, guys? So 6 on the left, and how many oxygen atoms on the right side? Somebody saying 5, 1, 2. Okay, guys. So here you need to count all the oxygen. So 1 plus 2, 3 plus 2, and that's 5. Okay. So please remember this table. Very good. 5 is the right answer. This table is very important because you need to make the count of atoms of each element. Now let's go ahead and see how to balance this. So you can see lead is balanced already, so we don't worry about it right now. And nitrogen is not balanced, oxygen is not balanced. So which atom is easy to balance? Nitrogen. Okay. So to balance nitrogen, we'll multiply by 2 here. So that's going to become 2, and oxygen will get disturbed, but don't worry. So 2 into 2, 4, plus 2, 6, 7. Right? So now lead is balanced, nitrogen is balanced, but oh no, oxygen is not balanced here. Can you see it's 6, and the table right now I've updated it to 7. So what do we need to do here? Since oxygen is less on the left hand side, we need to multiply by 2. So I'll just erase this N1 here, and to balance oxygen, let's multiply by 2 here. So now how many? So entire thing has got disturbed. So lead is going to become 2 here. So 2 Pb. Nitrogen is going to be, it was 2, but we multiplied by 2. So it's going to be 4. And oxygen was 3 into 2, 6. It was 6. We multiplied by 2. So we have 12 oxygen, right? And now if you see on the right, we have, so we've disturbed the entire thing, right? But we are not going to worry. So again, we are going to start with the easiest element because oxygen looks difficult. So let's start with lead again. So lead, we have 2 here and 1 on this side. So to balance it, we are going to multiply by 2 here. So this is going to be 2. And what is the new oxygen? Oxygen is going to be 2 plus, this is 2 times 2, 4 plus 2, 6, 7, 8. Right? Is my counting correct? So please make sure the counting is right. So we have 2 into 2, 4, 6, 7, 8. Okay. And so lead is balanced. Nitrogen is not balanced, right? You can see we have a 4 here and a 2 here. So to balance it, I'm going to multiply by a 4 on the right hand side. So this is going to become 4. So guys, can you see that? And now how many oxygen on the right side? So take a look. So the number of oxygen atoms on the right is going to be 2, 2 into 1 plus 4 into 2. So 2 plus 8 plus 2, 12. And can you see, so what do we have here? So this is going to be 12. And can you see that our equation is balanced? So here we balanced this equation, and this is the important thing. We just were balancing the simple elements, and then balancing the difficult one like oxygen turned out to be automatic. It automatically got balanced, so we didn't have to worry about it. Clear? So this is the important thing, guys, that make sure you start with the easiest element, not the most difficult one. And this table technique is very simple. It's very kind of formal technique where you can see the number of atoms on the left and right and make sure that each row in the table is balanced. Excellent. Now let's take a look at the hit and trial method. So till now we discussed about the table technique. Now we'll see the hit and trial method. So this is a very simple method. So table method is the basic method, and this you can use once you start becoming more comfortable with it, because this you are going to directly do it mentally. So let's see how do we do this. Again, the important rule is start by balancing the easiest element. Don't select the difficult one, okay? And then keep doing it till the equation is balanced. And I'm going to show you some special tricks with fractions also. Okay, so let's take a look, guys. So to balance here, you can see that sodium is balanced, 1, 1, 1 on the left, 1 on the right. So we are not going to make a table this time. Chlorine is 2 on the left and 1 on the right. So to balance chlorine, we are simply going to multiply by 2 here. So now chlorine is balanced, but sodium is disturbed, right? So there's 2 sodium there and there. To multiply it by 2 we get. So this is the quick way to balance it. Just mentally you go element by element and we've balanced our equation. Great. Let's try next one. So guys, can you try this? We have KClO3. When you heat it, it gives KCl, potassium chloride plus oxygen. So potassium chlorate on heating gives potassium chloride plus oxygen. So I want you guys to try this balancing this chemical reaction. Okay guys, so give this a shot. So try to balance it by the hit and trial method. So this we are not going to make a table here. So why don't you guys try this? Okay guys, so I want you to try this thing. So balancing, very good. I'm seeing some answers and you guys have the right answer. So that's great. So you can balance this by the hit and trial method. And let me show you one special technique here. So if you look at this equation, potassium is balanced. It's 1 on each side. Chlorine is also balanced. Can you see? So I'm seeing a lot of you got the right answer. Great. So chlorine is also balanced. Oxygen is the guy who's causing trouble, right? So can you see there's 3 oxygen on the left. So we have 3 oxygen on the left and 2 on the right side, right? So the simple way we can balance this is we are going to use the fraction technique. Since there's only one guy left, we can do 3 by 2 here. So now carefully look at this method. So now if you look, so if you do 3 by 2, what are you going to get? So 3 by 2 times 2, because it's O2 is going to be 3, right? 2 and 2 will cancel. So to balance it, you can apply fractions also. But we can't leave the final equation cannot have fractions. So what do we need to do? Since we have 2 in the denominator of the fraction, to balance the whole equation, we simply need to multiply by 2 here. Okay, so if you multiply by 2, it's going to become 2 KClO3, 2 KCl, and this 2 is going to get cancelled. So this is going to be 3 here, right? So our balanced equation is going to be 2 KClO3 gives 2 KCl plus 3O2. And as you can see in our answer, there are no more fractions left. So this is a very quick technique to use fractions and quickly balance the equation. Okay, so excellent. Let's try this one also. So we have another hit and trial method here where you have C4H10 plus O2 gives carbon dioxide plus water. So let's try to balance this with our hit and trial method. So the first thing we can see carbon is not balanced. So we're going to quickly balance it by multiplying by 4 here, right guys? And hydrogen is 10 on the left and it's 2 on the right. Okay, so it's easy to balance hydrogen by doing 5 here. Do you guys agree? Now how do you balance the oxygen? So oxygen we didn't do initially because it's more tough, right? There's CO2 and there's H2 on the right hand side. So to balance oxygen, now let's count the atoms of oxygen here. 4 times 2, 8 plus 5. So can you see that we have 13 oxygen on the right hand side, right? And we have only 2 oxygen here. So guys, can you see? So now again you can be smart and apply the fraction technique because only this guy is left. So to balance it, we'll need to do 13 by 2. Now can you see is the equation balanced? Because 13 by 2 times 2 is going to give us 13. So we'll have 13 on the left and 13 on the right. Okay, so now guys, but we can't leave the fraction. Remember, you're not allowed to read fractions in your equation. All the coefficients should be whole numbers. So we'll multiply the whole thing by 2. So if we do that, we are going to get 2. This will get cancelled. You'll get a 8 here and a 10 here. So our answer is going to look like this. 2C4H10, that's butane, plus 13 oxygen is going to give 8 carbon dioxide plus 10 water, right? So see here, we've done the hit and trial method and we've used the fractions also to get to the quick answer. All right. So guys, once you're comfortable with the table technique, you can start using hit and trial method, because as you can see, it's much faster. You don't have to draw the whole table. But of course, if it gets difficult, you can go to the table, or next I'll be talking about another special technique using which you can balance any difficult equation. Okay guys, so are you ready for the next method? It's called the ABCD method. Okay, so let's take a look. What is this method? So to apply this method, because the whole goal of the balancing the equation is to find the correct coefficients. So since we don't know the coefficients, we are going to put them here, right? So you can just say, let's say the first coefficient is A in this equation. Let's say the second one is B, C, D, and if you have more, you can write E, F, and so on. Okay, so take a look at this important method called ABCD method, right? And now for each element, you write down the equations for the coefficient. So first you write down the coefficients in the equation as I've shown you in the first step. And now for each element, you need to write the coefficients. You need to write the equation for the coefficient. So I'm going to show you that. And then the coefficient that occurs the maximum number of times, you can let that to be 1. You solve for the coefficients just like you do in mathematics, and then remember to remove the fractions. So let me explain you this method with the help of an example. Okay, so let's take a look. So don't worry, it's going to be clear once we do the example. So this is our equation. So let's put our coefficients here, guys. So you can do this on a pen and paper to understand this better. So make sure you have your pen and paper ready. So first write down the equation and write A, B, C, D, right? And now we'll make this table, right? So our table was elements. So what were our elements here? Nitrogen. What are they in this equation? Hydrogen and oxygen. Okay. And now we'll see how many nitrogen. We want the atoms of each element should be balanced. So let's look at the number of atoms of nitrogen on the left and on the right. So let's take a look. So how many nitrogen atoms on the left? Can you see? There's a number of atoms because A times 1. So that's going to be A here, right? And how many nitrogen atoms on the right? Can you see? It's C. Okay. And since we want them to be equal, we're going to write this equation A equal to C. Clear? Next one, let's look at hydrogen. So can you see how many hydrogen atoms are there on the right, left side, guys? So how many hydrogen atoms we have on the left? So it's going to be 3 times A. So this is going to be 3A, right? And how many hydrogen atoms do we have on the right side? Okay. So how many hydrogen atoms on the right, guys? Okay, so let's take a look how many hydrogen atoms on the right. Can you see it's going to be 2D? Very good. So a lot of you are answering that. It's 2D on the right side. So write down that equation. And now let's take a look at oxygen. So how many oxygen do we have on the left side? It's going to be 2 times B. So we have 2B here. And now how many oxygen on the right side? So take a look carefully. How many oxygen atoms are there on the right side of the equation? So oxygen is going to be, as you can see, there's C here and then there's D over here, right? So it's going to be C plus D. Right, guys? So you have 2B on the left side and C plus D on the right side. So we've got our 3 equations. And now remember, what is the important step? So we've done the second step. For each element, we've written the equation. And the coefficient that occurs the maximum times, let that coefficient be 1. So which coefficient? You can see A is occurring here 2 times. So we have 2 A's, we have 2 C's, we have only 1 B and 2 D's. So we have A, C and D, all 3 occurring 2 times. So let's take A equal to 1. Okay. So we are going to take here. So you can take any coefficient as 1, but it's important to take the one that is occurring the most times as 1, because that's going to be easy. So we have a equal to 1. Now if you look at that first equation, since a and c are same, so c is also going to be 1, right? Okay, and let's see what do we have here. So from this equation we have 3a equals 2d. So what can we say? 3 times 1, so 3 into 1 is equal to 2 times d. So we are trying to solve for these coefficients because that's our goal, right? So d is going to work out to be, as you can see, 3 by 2. Clear? And now you need to solve for b in the last one. So what does the last equation say? We have 2b is equal to c plus d. So c was 1 here and d turned out to be 3 by 2. So 2b is equal to 1 plus 3 by 2. So we have over here 5 by 2, and therefore b is going to be 5 by 4. So all of you please check my calculations. Okay, so this is what we are doing here. So if some of you are having doubts, take a look what we've done till now, and then we are going to check is the equation balanced. So what is this magic method doing? We are, since we don't know the coefficients, we are just going to put a, b, c, d here. That's what we put. And then we, using this table, we are going to check how many atoms of nitrogen are there. So we use this equation a equal to c. Then we have 3a equal to 2d. And using oxygen equation, we have this. And then whichever coefficient is occurring the maximum number of times. So here you can see a occurs the maximum number of times. So we're going to take a as 1. And so c is also 1. And then solving, we got d is 3 by 2. And solving this simple, you got 5 by 4. Okay, so let's go ahead and substitute this in our equation and let's see if it's balanced. So I'm just going to erase this here to make space. Right, so a is 1. So we've got 1 into ammonia, right? So 1. So what is b? We've got b as 5 by 4. So I'm going to write that here. So 5 by 4 O2. And c is also 1. So it's NO plus d is over here 3 by 2, right? H2. So guys, take a look. So I've just substituted the values of a, b, c and d into this equation, right? And now remember, we can't leave fractions, right? Because you can see there's a 5 by 4 here, there's a 3 by 2 here, that's not allowed. So to get rid of the fractions, you can simply multiply. So what should we multiply by here? To remove the fractions, we are going to multiply by 4, okay? Because you can't because to get rid of the denominators, we are going to multiply by 4 here. So let's multiply this whole equation by 4. And what do we get as a result of that? So this is going to become 4NH3. This will cancel. This is going to become 4NO, and 3 by 2 times 4 is going to become 6. So I'm going to erase this and write, or let me just cancel this here and write 6 here. Okay. So what are our final numbers? 4 ammonia, and this we can, and we have a 5 by 2 oxygen, and this whole thing turns out to be 6 here. So take a look, and I think we've balanced our equation. So this is the table technique. So sorry, this is the ABCD method. So guys, take a look what we did. We solved for the values of ABCD, and once you substituted here, we've got our balanced equation. So this is our final balanced equation, and you can check there's 4 nitrogen on the left, 4 on the right. If you check, hydrogen is 12 on the left, it's 12 on the right. Oxygen is 10 on the left here, can you see? So 5 times 2, that's 10. And here it's also, can you see, 4 plus 6, 10 here. Okay, so this is how you, don't worry, we'll take another look at another example of the ABCD method, but this is how you apply the method here. Clear? All right. So, and guys, if you have any doubts, you can write it in the comments below, or again, watch these steps after the live class, but you just have to practice out this method, and I'm sure you'll find it really easy. Okay. So are you ready to try the next one? So let's go ahead and try another one for the ABCD method. So here, if you look at this equation, if you try to balance it by the table technique or hit and trial, it might take you time, right? So let's go ahead and try with the ABCD method. So it's going to be A here. So we're going to first put the coefficients. So that's simple, A, B, C, D. And since we have another term here, we're going to put E here. Okay, guys. So just put down the coefficients for all the terms. Now again, let's make our table here. So our table is going to be the elements. And can you see what is our elements here? It's sulfur, hydrogen, nitrogen, and oxygen. Okay. And we are going to do the count of the atoms of each element on the left side and the right side, and we are going to equate it. Okay. So pretty simple. Just follow me. Just follow the steps and you'll find it really easy. Okay. So if you look at sulfur, how many atoms of sulfur on the left side? So guys, on the left side, how many sulfur do you have here? Can you see? It's going to be A atoms. A times 1. So sulfur is A on the left side, and on the right side you can see sulfur is going to be C times. It's because you have sulfur here. So A equal to C. Right? Now guys, let's take a look at hydrogen, the next element. So we have B into 1. So B times on the left side, and on the right side how many hydrogen we have? So it's 2 times C here. Can you see that? 2 times C from H2SO4, and then D into H2O, right? So that's going to be plus 2D. Okay, and there's no more hydrogen on the right. Clear? Okay, next let's take a look at nitrogen. So nitrogen is going to be, again, there's B times 1, so B nitrogen on the left. Okay, and on the right side we have E. So we have B equal to E. Okay, clear? So we're just going element by element and writing the count of the atoms on the left and on the right hand side. So it's really simple. And oxygen we have 3 times B. So B into 3, so that's going to be 3B. Okay, so please remember there's O is 3 here, but you have to multiply by B, the coefficient. Very good. So Srinivas says 3B. So that's 3B on the left. And now you take a look at the right side. Okay, so how many do we have of oxygen on the right? So you are in H2SO4, you're getting C. So there's O4, so 4 times C. So that's going to be 4C. Plus you have a D there, plus D. Okay, and plus 2 times E. So guys, check my equation if there's any error, right? So just go element by element and write down the number of atoms. Now let's take a look. So you can see that A is present once. Okay, only once here. We have C, which is present 3 times. B is present 3 times. D is only present 2 times. So I think we're going to take, so the element which is present the most number of times, we're going to take that to be 1. So it can either be C or B. So I'm going to take here as C to be 1. Okay, right? So if C is equal to 1 from the first equation we get, so from this equation we get A is also equal to 1. Okay guys, so just take a look. So simple, C is equal to 1, A equal to 1. Now what do we get from that? Let's go ahead and take a look at this one. So we've got B equal to, so this equation is going to become B equals 2 times C, since we assumed it to be 1. So you can take it any one to be 1. So that is 2 plus 2D, right? And B is equal to E. So we can't do anything about that. And for this equation, we are going to get, so this is going to become 3B equals 4 times C. So that's going to be 4 into 1, 4, plus we have a D plus 2E, right? And since we have B equal to E, so instead of 2E, I'm going to write 2B here. Okay, so can you see that? Since B and E are same, so we're going to write 2B here. And so if we simplify this equation, 3B minus 2B, so it's going to be B equal to 4 plus D here. Clear guys? So it's just doing some maths with this. I know sometimes this may look a little difficult to solve these equations, but you know, it's much easier than trying to balance the entire equation. Okay. Okay, I think some of you are having a little trouble in understanding. So let me explain you again clearly. Take a look at this ABCD method. Nothing special here. So I'm going to explain you again. So if you look in the original equation, you're just putting these coefficients A, B, C, D, E, okay? And then simply like the table method, you go element by element. So let's say we started with sulfur here, okay? So sulfur's A equal to C because A and you have C on this. Similarly, you do for hydrogen because hydrogen there's B atoms on the left and 2C plus 2D on the right, and same way for nitrogen and oxygen. Now the only task is left to solve for the coefficient. So do some maths, and before you start solving, you can take the coefficient that occurs the maximum number of times, take that to be 1. So we took here C equal to 1, simple. And then on solving, since A and C are equal, we got A equal to 1. Okay, great. And so now what do we have here? So we have these two equations, B is equal to 2D, and we have our second equation, B equal to 4D. So can you see we have two linear equations in two variables, or what is known as simultaneous equations. So it's simple, you just solve for them, and it's quite easy to solve for these because since both have B on the left side, we can just equate it. So equating equation 1 and 2, I'm going to write 4 plus D is equal to 2 plus 2D, since both is equal to B, right? And solving, we are going to get D equal to 2. So if you solve this, we get D as 2. So can you see we have solved for C, A and D. Now we can easily find B from this equation. B is going to be 4 plus D. So B is going to turn out to be 6. And since B is equal to E, E is also turned out to be 6. So it's really easy to solve this, nothing special here. You're just doing some basic maths and solving these equations. So can you see we've solved all our coefficients. So now let's replace them and see what do we get. So A is 1, so it's going to be S plus B is 6 here. So 6HNO3. And can you see what is C here? C is 1, so equals H2SO4. Plus D is, what is, we solve for D, D is 2, so 2H2O, right? Can you see that, guys? And E is equal to 6, so plus 6NO2, okay? So that's what we are getting as our answer. You don't believe me, you check it yourself. Don't believe what I've written. Assume there's some mistake here, so go ahead and double check it, right? So this is the concept here, that just write A, B, C, D and E and solve for the equations. Okay, it looks a little complicated, but once you do on pen and paper, it's really easy. The numbers are pretty simple, and if you have any fractions left, remember you need to multiply it so that you get the you get whole numbers. You can't leave fractions in your final equation. So let's do a quick double check over here. Can you see sulfur is 1, so it's balanced. So always remember in your test, you must check is your equation balanced or not. So sulfur is 1, 1, hydrogen is 6 on the left, and how many hydrogen here? 2 plus 2 times 2, 4, so that's 6, excellent. Nitrogen is 6 here, and nitrogen is again 6, and oxygen is 6 times 3, so that's 18, and here it's going to be 4 plus 2, so that's 6, and you have 12 here, so 6 plus 12, 18, excellent. So our equation is balanced, and trust me, if you had tried the hidden trial or table technique, it would have taken you most probably much longer to solve these kind of equations. So please remember to use whichever method is convenient for you, but if it's getting difficult, this coefficient method or what is called the ABCD method really helps. So one important thing is, guys, do remember to check after your equation is balanced, because you shouldn't say in the test, oh, my equation was incorrectly balanced, because after balancing it, do the quick check that the numbers of atom on the left hand side and right hand side, are they equal or not. So make sure you're checking that the number of atoms of all the elements, not just a few, on the left and right are same. So the equation should be balanced. And another very important thing, there should be no common multiplier in this equation. So this is a very common mistake. Can you tell me that what is the problem with this equation? Is the equation that I marked here, so this equation that you see here, 4H2 plus 2O2 gives 4H2O, is this equation balanced or not? Guys, can you tell me? So is this equation balanced or is it not balanced? Okay, so is this equation looks balanced, right? But what is the mistake in the balancing here? Is there something, is there a problem in this balancing? So if you take a look, hydrogen is how much on the left? So our two elements are hydrogen and oxygen. So we have 4 times 2, 8 hydrogen on the left, and we have 4 times 2, 8 on the right. And we have 2 times 2, 4 on oxygen, and 4 times 1, 4. So both hydrogen and oxygen are balanced, right? So this looks like a nice balanced equation. So we should say that our answer is correct. But actually, it's wrong, right? Because you have overbalanced it. Can you see that there's a common factor of 2? So if I divide all these coefficients, if we divide it by 2, right? What are we going to get? It's going to become 2H2 plus O2 gives us 2H2O. So that is the correct balanced equation, right? That where you don't have any common multiplier. So can you see that there's no common thing over there that here we divided by 2, so there's no common factor, right? So another way to say no common multiplier, I mean that there should be no common factor in the coefficients of the equation, right? So in your coefficients, there should be no common factor. So check that, because sometimes this is a common mistake in the exam. You overbalanced it. Okay, your equation is correctly balanced and all, but let's say it's multiplied by 2 or by 3. So don't be generous with your numbers. Try to use the smallest numbers possible. And this is a very, very important tip. At the end, make sure there's no common factor in the coefficients. Otherwise, and you can simply balance it correctly just by dividing it by 2. Okay. So now big question is, so we've learned, so what are the methods that we've learned in this class? We learned the table method, the hit and trial method, and the ABCD method. And I told you the other important thing is patience and practice. Sometimes while doing balancing of equations, we lose our patience. So we say, this is not happening, I'm not able to balance this equation, it's not working out. Don't lose hope. Try it, make sure your countings are correct, make sure you've written the correct equation, and keep trying with the easiest element, and I'm sure you'll do it. Now, a common question is that which method should we use? Okay, so here's my recommendation. First, practice the table method, because that will give you an idea how you're balancing, what you're balancing. So this is always a good method to start with, right? So start by practicing this method first if you're not comfortable with balancing equations. But once you've mastered the table method, you don't need to use it as often, right? So after that, I would suggest the first thing to do is go directly for the hit and trial, because hit and trial is fastest. Just multiply with the numbers and try to balance the equation quickly, okay? Because that will save your time in your exams. So go for the hit and trial method. If you don't feel comfortable, you can always fall back to the table method if you feel the numbers are not working out, okay? So guys, remember this, go for hit and trial first. So this should be your first option, right? And if it's turning out to be really difficult, because believe me, some balancing are tough, it takes time, and with hit and trial it gets frustrating because it's not balancing, then this should be your best second option, the ABCD method. Because what is good about this method, it is foolproof, right? If you write your A, B, C, D, E, whatever coefficients, and you sit and crunch the numbers, you sit and solve the numbers, you're definitely going to get the correct answer, okay? So hit and trial method, and if it's not working out, go for the ABCD technique. For those of you who are comfortable, who like using the table method, you can do it, okay? But it's more time consuming. So this is my recommendation, hit and trial. Otherwise, if it's working out, it's difficult, go for the ABCD technique. Okay guys, and don't lose patience, keep practicing it. And here I have some questions for you to solve. So this is your homework. Try balancing these two equations. So I have two equations for you here, equation 1 and equation 2. Okay, so these two equations, right? So this first equation and the second equation, Pb3O4 plus HCl gives PbCl2 plus H2O plus Cl2. So first check, is the equation balanced or not? If it's not, balance it. And same for the next equation, copper plus nitric acid gives copper nitrate plus water plus NO. Okay, and one very important thing guys, don't learn up the balancing numbers, okay? you should practice balancing. Don't start learning equations like 2 KCl gives 2 KClO3 plus 3O2. I know many students do that. Some of my friends used to do that. That's not a good option, right? You must practice balancing and balance in the exam. Maybe if there are 3 or 4 very difficult equations in your textbook, you can learn those to save time of balancing in the equation. But please don't learn balancing numbers. You should be comfortable, you should learn how to write equations with the help of atomicity and valency, and practice balancing. Become fast at it. I want you guys to become great at balancing and do it well. And so this homework question, please go ahead and write your answers in the comments below, and go ahead and use the hit and trial method or table method, whichever you're comfortable with, or the ABCD method, because some of these equations you might find difficult. So if hit and trial is not working, you can go for the coefficient technique. And I look forward to reading your answers. So try these 2 homework questions and write your answers in the comments below. And I've got some more videos for you on chemical reactions and equations. So you can watch this video. So just search for chemical reactions and equations, Manocha Academy. And you can also look for this video, the types of chemical reactions. So these 2 videos will be very helpful for you. And this class was on balancing chemical equations. So once you watch these 3 videos, I'm fairly confident that you'll become a master of chemical equations. Okay, so you'll be able to really master the equations and balance them easily, and you really understand how to convert word to chemical equations. Okay, and I know a lot of you are asking when is the live class. I'll keep on taking more live classes on physics, chemistry, and maths. Live classes also coming up. So guys, do hit the subscribe button, and if you haven't liked this video, hit the like button right now, and also hit the notification bell so you guys get notified about our videos. So usually I'll be taking the classes in the evening. I'll try to take classes every day or maybe alternate days. So I'm trying to take more and more live classes, guys. So thanks a lot for your support. Yes, I'll be taking classes of physics, chemistry, mathematics, and guys, it's awesome to read your comments, and please do share out our video with your friends. And as I said, if you haven't checked out my website, do check it out. Our website is manochaacademy.com, and we have courses on physics for class 10 and class 9, the full course. And these courses have interactive videos. They have quizzes and questions for you to practice. You can ask your doubts and get replies from me. So they're really helpful in your exam preparation. And we have great discounts going on for these courses right now. So do avail those offers. They're for a limited time. And guys, thanks a lot for your support. Hope you enjoyed this class. So do hit the like button and share it out with your friends. And all the best. I'm sure you'll become confident at chemical equations. So keep practicing, and I'm sure you guys will do great. Okay, so take care everyone. Thanks for watching, and do share out this video with your friends. Thanks a lot.